set, but I would like to thank the organizers for inviting me. I'd like to thank Dr. Moyo for remembering that one of his own is still around and is still working in the space. I think the last time I was here or addressing or speaking at a water event, I think it was 15 to 20 years back, and it was in this very same venue, if I remember correctly, Dr. Moyo. I remember there was Arnold Payne. He was sitting there, and on that day, he stood up and he said something interesting. He said, "Sokutelwe," if you remember, Dr. Moyo, that we were here. And when we asked him what he meant, what are you saying? He said, "No, I see light," because I think there was somebody who was presenting saying the Matabeleland Zambezi water project is about to happen. So that was about 15 to 20 years back. Unfortunately, Arnold Payne, one of the very strong campaigners for that Zambezi water project, he passed away, but I think he still is act in our minds as somebody who really worked for the project to actually go on. Maybe just about myself. I actually was at the National University of Science and Technology. I'll explain why that particular subject. When NAST was established, they set up a unit, they set up a faculty, and they also set up what they called Bachelor of Civil Engineering, Civil and Water Engineering. Now, you won't find that anywhere else. You only find it here, because the fathers of INAST, the ones who built it, they felt that there has to be a focus on water, because in Matabeleland, there is a water problem. So that is an example of how you can actually take political inclinations and policy and influence what is happening in academia and bring out a whole crop of engineers or professionals who are supposed to solve the problem of the day. I don't know how much those engineers are participating in trying to resolve the issues in Matabeleland, but we come from that crop of people and the understanding that we were told initially about what needs to happen. Okay, now back to this the conference, the water stuff. Water is a problem internationally, everywhere. In fact, there was a prediction at some stage that the next World War III is going to be over water. I don't know if you heard of that. And it is something that is actually occupying a lot of governments throughout the world. Some governments, for example, if you look at what the Chinese are doing, it's an asymmetric way of trying to resolve a water issue, but you must realize what exactly is happening. So the Chinese have this concept that they are going to buy land somewhere in Africa next to Lake Victoria, and that is where they are going to farm, and that crop goes straight to China. If you look at it simplistically, you just think, oh well, it's great. Yeah, they want more food production. But in actual fact, they're actually managing their water issues that they've got. It's the same thing which we are seeing even around clean energy. There's an issue of clean energy that we're dealing with at the moment. And the issue of clean energy, what is happening? Europe does not have sunlight, and they don't have wind. So what they do, and they are proposing, is that they come to Africa where you've got very good sunlight, and then convert certain parts of water into hydrogen and export that hydrogen to Europe and reconvert that hydrogen into electricity. So in actual fact, you are exporting. It's an asymmetric way of actually exporting natural resources to other places. So the same thing around water. If you see these things, sort of things happening, you must actually see it for what it is, not necessarily just a farming expedition. It's an exportation of your water. I come from an organization called the Center for Scientific and Industrial Research. It's 80 years old. It was formed in 1945, just close to the end of the Second World War. So this organization was formed because technology was becoming part of a very strong factor in fighting World War II. And then the British actually then established these CSIRs in many places. There's one in India, there's also one in Kenya. So our task as CSIR is to research on technology and actually to deploy that technology in any sector within the economy that is established a need or challenges that need to be addressed. So I am from so you've got various divisions, but these divisions actually work together when a problem comes up. So I'm from a division called Smart Places, and I actually handle issues around technology in infrastructure, and we sort of come up with solutions for technological problems. So in today's topic, I am going to zoom into the Gauteng province. I think when you look at the Gauteng province, there are quite a lot of similarities when you look at Matabeleland. Gauteng province is a water scarce area. It's very water scarce, and it's got huge problems in terms of the water, where to get the water. And it's also sort of landlocked. It's one of it's actually the smallest province in South Africa. It's only about 1.44 square kilometers, and but it contributes about 34% of GDP. These statistics are very important because I'm defining the situation so that you see how water is important in the Gauteng province. So it is mostly, the economy is mostly around services, which are 80%, then manufacturing 14%. Manufacturing has gone down a bit, and then you've got the other primary sectors. It's got a population of 16.1 million. I did hear some of the colleagues who were talking about the cities. This is a very important matrix. You have to measure everything. If you find yourself in a scarce environment, you have to measure even the smallest, tiniest drop that you've got. So you need to measure how many people you've got, and you have to project. So our current projections are that the Gauteng economy, the population is growing at around 300,000 people a year, which is about 1.8 to about 2.2%. So as those people come in and you project in the next 25 years, you know exactly how much water you are going to require. So this is just to show, I think a lot of people have talked about this, just how the whole system works. It starts off, you're from your dam, water treatment, up until you get to your homes, and then after that, they come sewage, and then that sewage, it comes back, it has to be treated, and it has to go back into the river as treated water. And then the other water collection structures on your roads, you've got on the side of the roads, you've got those water structures that people normally don't take care of, but they're part of the ecosystem, or your water structures. So in terms of demand, Gauteng actually has got about, the demand is about 5,000 megaliters per day. I had some colleagues here also talking about that. And then our calculation is about a person should consume 200 to 250 liters per person per day. I heard there were some figures that were going around, they said 65 or something like that, our calculations is that it should be 200 to 250. So that water goes into a lot of things, about 60 to 70% of that is domestic. We have got a map of every single little river in the Gauteng province, even a small one. It's mapped out. We've got maps. You dot it, you map it. This is the amount of water that you have. And the biggest water source is the Vaal River, and you've got others like your Klip River, your Stone River, your Jaskei, and so forth. And the Vaal Dam is undoubtedly the bigger one. It supplies the most of Gauteng, and then there are smaller dams which are really not enough for water, but then the Redflea Dam supplies 15% of Pretoria's water. So Gauteng sits on a ridge. This is why it is water scarce. It is situated in the watershed, so it divides. Some of the water goes to Limpopo, some of the water goes to the Vaal River, into Namibia, and into South Africa. But because there is no water, it's a water scarce. There was a solution that came up to actually get water from Lesotho. So most of the bulk of the water in Gauteng comes from Lesotho, from a project called the Lesotho Highlands Water Supply. So basically the water comes from, it was built in the Lesotho Highlands, and then it is conveyed to dams, and that water is then pumped through a tunnel, and then it goes and it feeds into the Vaal River, and that water is then collected. I think it's almost the same concept as what needs to happen here, or what was being planned. Water comes from Zambezi, is pumped into Kwaishangani, something happens there. And then the water is then distributed through Rand Water. So there is a water body, it's not a water body, there's a company called Rand Water. That Rand Water then is the one that then distributes that water to municipalities through a range of pumping stations throughout the Gauteng province. And it goes through, and to manage demand, you know that you then need to put up these water reservoirs so that if the demand is going up, then you can distribute it. So you need to manage that. You can't pump water directly from one pumping station straight into people's properties. So I am going to speak much on the Lesotho Highlands because it's a funding issue. It's a funding example of what you can do with infrastructure, water infrastructure, and which are the types of players that you can bring in if you want to build something massive like the Lesotho Highlands water project. So there is in this project, which is now basically what supplies water in Gauteng. You've got the National Treasury, you've got Department of Water and Sanitation, you've got what is called the Trans-Caledon Tunnel Authority, Rand Water, you've got municipalities who distribute water into people's homes and charge people for that. You've got the Development Bank of Southern Africa, then you've got the Water Research Commission that tests the water and makes sure that everything is fine. So this is the responsibilities of each and every one of these institutions. So Department of Water, they provide the national policy, water licensing and regulation. It owns national dams and transfer schemes. So it owns all the dams. I heard Uba Mukomo talking about who owns. So they own all the dams. And then there is the Trans-Caledon Tunnel Authority. That one is owned by South Africa. So it finances and implements major bulk water infrastructure. So that's the financier. Then you've got Rand Water, which provides bulk water for the Gauteng province. And then you've got municipalities, then you've got the National Treasury, and you've got the private sector. There's PPRIZ. There are all sorts of banks that are involved there. Some of them are European banks, but they're all involved in this scheme. So basically, what happens there is that if you do have a bankable project on one hand, on the other hand, you've got customers who pay. The people in the municipalities know how to collect that money and collect it properly. You've got a bankable project. The same principle applies on roads. If you've got roads and you can put tolling, then you can get funding, and a lot of people will be interested in that funding. Then there's this reticulation which happens. So how was this thing set up? And if you want to do it, how would you do it? So step one, the Lesotho government set up the LHDA, and South Africa set up the TSTA for South Africa, which borrow money from the international lenders and capital markets. Then step two, you build the infrastructure. You've got the money, you build it. Step three, South Africa starts receiving water and makes its monthly payments, the fixed capacity charge and operation and maintenance charge, which is then paid to LHDA. So the LHDA then uses a portion of this revenue to service the debt, to fund operations and maintenance, and to pay royalties to Lesotho, which is a crucial part of the treaty. Then step five, the revenue from Lesotho's own hydropower cells helps also to repay the loans taken for the hydroelectric components. And these are as I've said, the main players. African Development Bank is there, and various banks. So in terms of the flow of money, the users, water users, are the ones that are expected to pay for this service through Rand Water, through municipalities, through Eskom, through Sasol. Eskom uses a lot of money for generating, they use a lot of water for generating electricity, and Sasol also uses a lot of that because they also use it for their plants. And then the money goes to the SA Department of Water and Sanitation, then Trans-Caledon, and then the government of Lesotho, and then water flows in the opposite direction. But then with these processes, of course, there are challenges. I think I have heard some of the challenges that were being said here. It's the same type of challenges where you've got missing water and revenue, unpaid for and lost water. We monitor this water very closely, the flow of water, the pump stations and so forth. We monitor it throughout the system, and the municipalities have got a duty to then monitor the water that they pump into people's houses. But we've got problems where people have got illegal connections, I've heard about that, and there are water leakages, and these problems are the ones that then are brought to the CSIR to say, can you please resolve this problem of these water challenges? You've got several of these municipalities within Gauteng that actually have got even up to 50% of water losses. And you then, if that whole process and that whole supply chain of water has to work, then you have to resolve these problems at that level. And then there are supply interruptions. Someone spoke about that, and some of them are caused by we had a problem of electricity where there was load shedding. So there is a water energy nexus that we are actually working on that needs to be resolved. So there are supply interruptions. In some cases, there's a pump station called Ekenhof, which supplies water to Soweto, Johannesburg. If that pump goes out just for 2 hours, it affects the whole area for a week. So you need to sort out this energy nexus if it comes to water. And of course, you've got this wastewater flow into rivers, and that also has to be resolved. And so we also have this problem of acid mine water. There are a lot of mines in Gauteng. In fact, Gauteng is sitting on top of tunnels. All those tunnels, old tunnels, are now full of water. And that water reacts with the minerals, and it causes acid mine water, which is rising. So we were given the task of also resolving this issue of this acid mine water. So what were the solutions? So realizing that all of these municipalities are not on the same page. The first step was then to say, okay, let's create dashboards for everyone. So we measure on every single day how much water is being pumped, how much services are being executed, how much bulk water is being sold from run water to municipalities, and we also check the revenue that is coming from the water and we compare it to the water that is coming in. You manage that because every drop in Gauteng actually matters. And then there's the issue of the energy, water and systems. We then came up with a whole range of putting in together alternative energy sources and to make sure that those pump stations do not run out of water. We also built solar farms to make sure that they are always with water. And then the Gauteng government then came up with, they asked us to write them a strategy for smart cities. We came up with a strategy for them on how we can have a connected, sustainable and inclusive urban spaces. So basically, how do you instrument and create digital twins of that whole network? So basically, what we needed to do was to instrument from the side of raw water. When instrument, you put sensors in the raw water reservoirs. So basically, you know at what level those are. We've got sensors in the treatment plants. We know the quality of water. We know the level of water. We know at which rate we are pumping that water. And we also know the decay of water. When water goes through a pipe, it decays. We know exactly how it is decaying as it goes to people's homes and whether it's safe for drinking or it's not safe for drinking. And then we also now, we then put sensors, the project now is at a stage where we want to put sensors in pipes in certain strategic areas so that we know exactly how much water is going through those pipes, going into those particular areas. And we then created a center where you've got people who sit and watch that water flowing on a daily basis. Because water is of such, it's gold in actual fact, we want to measure everything about water, where it is, what it's being used for, and its status. And then we then put in analytics. So in pumping that water, we are going to then use AI to determine exactly predictive analytics. If a pipe bursts, let's say in this vicinity, we will know exactly at what time the next neighborhood is going to start losing water, or by the time the first person calls and says, I've got a problem, we will know exactly at which point that will happen. We will collect all this using deep learning and machine learning and data mining, and then collect all that. So this is being done specifically to manage. It can be done. When we started this, somebody was saying it's expensive, and then we said no, wait. The value of sensors has gone down, extremely gone down, to such an extent everyone in this room is carrying sensors in their pockets. So you measure your blood pressure, you measure your what, when you're walking, it measures your footsteps and so forth. So actually instrumenting these things is no longer expensive as it was before. So you can transmit all that information into a central place, and you can actually then be able to connect all those devices into one central position. I think I'll not bore you too much on that. And then the second one, there was a comment around one of the dams, which is said to be contaminated and so forth. We are now we have come up with a system to actually clean acid mine water. Acid mine water has got all sorts of things that you will never want in your body. It's got aluminium, water, zinc, iron, and so forth. We're taking that water, and we have created a system to purify that water so that it's usable and it's drinkable. So we are doing that in the West Rand. where we are going to be pumping all that water, purify it, but we are going to convert that water, some of it into hydrogen, and some of it we are going to use it as water for some of the farms. And with that, we are going to produce water from the solar farms that we're also going to be putting in those areas. So this work is over and above certain things. It's over and above replacing your water pipes. One of my first projects when I landed in South Africa from here was replacing water pipes, the old water pipes, the asbestos. You then replace them with the 110 PVC pipes. That was one of my first projects. We replaced in places like Alexandra, small places, and then bigger places, Weinberg and that experience tells you the moment you replace those water pipes, your water leakage goes down drastically. You begin to see what is happening, you see the pressure, you see all of that. So you need to do that because you can pump as much water as you want, but if there's a leak somewhere and the leaks all over the place, you're going to be just draining expensive water which you do not know where exactly it is going. You need to resolve that first. And then the second part, you need to resolve the leakages when water goes to people's houses. When I was working there, I found out a lot of people had illegal connections, but it was not poor people only. I worked in Horton and I was shocked one day. There was a president of one big company. He had a 110 millimeter pipe going into his house and he wasn't paying for anything there. So we're shocked to find that. So it's not a poor thing, poor person thing. It's actually a very bad culture of unruliness. So you need to fix that. And then you also need to then, there is a phobia for smart meters. I think the issue of smart meters, you can have a smart meter which is not prepaid, but you need a smart meter because that is where the world is going. Every household must have a smart meter because you want to measure that stuff. But not necessarily to say it must be prepaid because some people don't like prepaid, but you must have a smart meter. Those things are now not expensive. They are really not. I don't know about here. I wouldn't comment. I've been away for a long time, but you need that. And then the other thing is that, okay, my time has come to an end. Then the other thing that you then need to do is to make sure that you've got social justice. You must have a small amount of water, not small amount, but reasonable. In Gauteng, it's about 50 liters per person per day. Is it 50 liters per person? Yeah, something like that. But you must have that because water is life. You can't just cut people because they don't have money. There must be a minimum, a bare minimum. Okay, so I think I've said quite a lot and my time is up. In conclusion, we forget that the water cycle and the life cycle are one. This was a statement by Jack. And then when the well is dry, we know the value of water. So I think that is what is happening now in Gauteng and here in Matabeleland, and we need to take a look at that. Thank you very much. I think I'll end here.
When the well is dry, what happens? You'll know the value of what? Of water. And before I let you go, Masuku, before I let you go, why don't you just grill you? Now. We will grill you. Just remain here. I thought I was going to spare him this. Are there any reflections? I need 3 burning issues. 3 burning issues from our regional lessons. Going once? 1? All right. I said 3. Okay, 2, 3. We're done. No. I said 3. Next time when I say issues.
Is an issue of conceptualizing the concept of smart meters, of course, that are not prepared. And how can they work in a scenario like ours where you have constant electricity cuts and very poor access to network? How can that work?
solution that you're utilizing? Currently, I think it's a problem that we have in the Deka River, in Wange as well. Is it some technology that you guys are willing to share?
Thank you. We're giving to Kumar right here inside. In a circle.
You mentioned that you got acid from mines. Do you have any problems of leachate from those mines into potable water that's supplied to Gauteng? And how are you solving that problem?
Those are the 3 questions we're taking for now.
Yeah, I think the first question is about smart meters, connectivity, and all of that. Yeah, I mean, you can, for every technological challenge, there is a solution, and one of them in such scenarios is that meter can transmit whatever it's collecting when it picks up network later on. So you can have that gap. We do that in other systems as well. In transportation, where if you're tracking or a vehicle, or you're tracking its performance or telematics, or a train, in areas where it doesn't have, it just collects information. The moment it does, it then sends out in packets, sends out that data. In actual fact, you can even make it that it transmits only on a particular day. So you can play around with those parameters, and it's actually possible. In terms of same thing with the power and all of that, you can connect it in a manner that it stores certain power, it picks up at a certain point. They don't use that much power. At least the ones that I know, because the others you might not know, depending on how they are designed. And then there is the technology. Yes, the technology is patented, but it's available. It's available. It's almost available at the very low cost, but it's available. We can actually come and go through what the technology entails, and if you are competent to actually run the whole system by yourself, you can then run it by yourself. But it's got a patent on it. And then leaching, yes, it does happen. The water is rising to such an extent. That's why we were then brought in. It's a big problem. They are underground, almost dams that it's going up. So we need to solve that problem as soon as possible. We're actually running against time, but we now have a system to do it, and we're going to start doing it now. Start pumping some of that water. There's already one that is already operational in the Cullinan area, almost just outside Pretoria, where we are pumping the water and actually cleaning it already. So the system is there. I've got it here. I can show you if you are interested, but it's already, we're already pumping. It's a huge problem. So I think that example is just to say that water, you can clean water, even if it's wastewater, you can clean it. You can clean water even if there was a dead person in there. You can clean it. It's still water. And for your information, for us who work in these areas, I can tell you now, there are instances where, for example, we had an issue in Western Cape in Naisna. They found a dead person in a reservoir. You can imagine how that person got in there. It's still a mystery, but there was a person in there. So it's, and even some of the waste, these sewer collection, no, not stormwater collection systems that run, in some cases on the grids, You find all sorts of things, and I wouldn't want to describe what you find there, but it's still water. You can purify it. You can even make sure that it's so pure that it doesn't even have a single impurity in it, but it still remains water. It's hydrogen and it's oxygen. You can drink it. Yes. Yes. Yes.
Household setup. It starts off being impure, and therefore water can be purified to a standard that is accepted as long as it meets the set standards, which can be South African standards or World Health Organization standards.